All right, can you guys hear me? I can hear me. All right, I don't have a clicker, but I can use the arrow keys pretty well. So I'm excited to be here. Welcome, thank you for coming. I'll be talking a little bit about ExxonMobil's journey to unleash time series data with open source technology. I feel pretty lucky. This is actually my second time speaking at DataWorks Summit. I got to come here last year and talk about ExxonMobil's journey with setting up a big data lake. And this is kind of a continuation of that story. I'll be talking a little bit more about how we're using it now. Before we get too far into that, one of the first things I want to do is just introduce myself, let you know who I am, and a little bit about my background so you can understand my point of view. My name is Kevin Brown. I've been with ExxonMobil for about 6 years. And before that, I had a little bit of experience with software development and web development. I've got a degree from BYU, or Brigham Young University. And since I came to Exxon, though, most of my experience was with Linux systems administration. And having the development skills and the Linux systems administration actually lended itself quite well to slide into Hadoop administration. And my title today is a big data platform engineer, which we made up. It basically means I'm a glorified Hadoop administrator. Before I jump into the main content, one of the first things we want to talk about real fast is what I'm going to be talking about, as well as what I won't be talking about, just to make sure that we're all in the right place. So I'll get these up here. So one of the first things I'll do is I'll talk a little bit about what time series data is. Most of you should already know that, so that will be brief. But I'll also talk about why it's so important in general, and then why it means so much to ExxonMobil, and what we're trying to empower our users to be able to do with that data. From there, I'll talk about how we actually accomplish that. So one of the first things I'll go into is Apache NiFi and how we're using that to collect and ingest data. And then from there, I'll move on to Apache Spark with some of the challenges that you might look into or that you might see once you start working with the data and after it's landed. And for us, that was actually quite challenging. And then going forward from there, we'll talk a little bit about Apache Hive and Hbase. And then at the very end, I think I've actually got one more here maybe. Yep, we'll talk a little bit about consumption APIs. Just to be clear, I'll go into a little bit more depth about the Apache NiFi pieces, and I'll give more examples there. It'll be a little bit higher level when we start talking about Spark, Hbase, and Hive. That'll be more about things that you need to be watching out for. You're not going to see any screenshots or any code examples. I'm not going to give you any Hive schemas or Hbase schemas or anything like that. But I will do my best to give you guys good examples and things to, again, be looking out for if you're going on a similar journey, especially with time series data. So with that being said, we'll go ahead and jump straight into it. So what is time series data? So a real simple definition, it's a series of data points indexed in time order. But an easy way to think about that is if along your x-axis, you'd have time intervals, and then on your y-axis, you would have your values. And if you draw those points together, you'll typically get a nice little trend, a line graph just like this. And that's nice because you can see where your data's been, where it is currently, and usually you can make a pretty good guess about where it's going in the near future as well. And the bigger your data set, the more you know about your data. So this is important for everybody. And at ExxonMobil, we're a fully incorporated gas and oil company, which means we handle from the very beginning all the way to the very end with our products. But I'll be focusing mostly on our refineries and our chemical plants for the purpose of this conversation. So we've got refineries all over the world, several different continents, many different countries, and we're collecting data from millions of sensors across all these refineries. And not only that, but we're not talking about just recent data, but we've got that data going back decades. Now, this data has always been really important to us. It's always been critical. It's absolutely necessary for our operations, for our safety, optimizations, and so on and so forth. But our engineers typically would ask questions like, show me all the sensors for this particular component in one of our refineries for the last 2 weeks. And that's a pretty easy question for them to ask, and they can get quick answers with the systems that are already in place, the legacy systems. But they want to ask bigger questions. Show me 6 months for these 5 sensors. And they can still do that, but it's a little bit slower. But as your questions start to get bigger, they start hitting the limits of some of these legacy systems. They want to be able to ask questions like, show me all the sensors for this particular type of heat exchanger for the last 5 years across all of our refineries. And that's something that in the past has been pretty much impossible. I mean, they can ask the question, but in order to get answers, they'd have to break it down into much smaller questions and then try to somehow stitch it all back together, to the point where it's just not even worth doing. So we want to empower, enable our users to ask those kinds of questions, the big questions, the hard questions, and then have them, empower them to get answers to those questions quickly. So one of the first things that we got to do to go about accomplishing that is collect the data, go find it at all the sources. So we use Apache NiFi pretty heavily, and with Apache NiFi, real quickly, just my personal point of view, this is one of the tools that I work with quite a bit. I like it for a few of the different reasons here. So interoperability. If you're not familiar with NiFi already, one of the things I love about it is that it can speak a lot of different languages, it talks in lots of different protocols, and it makes it really easy to connect it to lots of different types of systems. In our refineries, we have several types of different systems, but also each refinery might be a little bit different from the next, and our chemical plants are a little bit different from our refineries as well. So that's important to us, that we can use pretty much one tool to collect data from almost all of our sources. And then ease of use. I like breaking this up into two pieces. So I've got a little bit of background with coding and automation and all that, so I don't mind getting my hands dirty and getting down in the ones and the zeros. But it's also pretty nice to be able to just literally drag and drop components. If you haven't seen a session on NiFi already, I recommend doing so. You'll learn more than what you'll learn here about NiFi. But one of the other things that I feel like people fail to point out is when you're using NiFi and you're building something, it's not just the fact that it's easy for you to build, but then I could take one of you that maybe isn't familiar with NiFi and just show you one of my flows. And just by looking at it and reading the labels on some of these flows, you can understand exactly what's happening. And you might even be able to make recommendations if you know the use case well to basically add to that use case and say, hey, what about getting data from this source as well? And can you plug this here? And can you redirect that there? It's a really visual tool. And I love that. I'm a visual person. And then lastly, really not lastly, there's a lot of things I like about it. But lastly, for this slide, you have a lot of control over what happens with your flows. So being able to move it, compress your data, reroute it, redirect it, control your scheduling, all those types of things make working with NiFi really nice. And it simplifies a lot of those tasks that might be a little bit more difficult or take up more time if you're doing it with another tool. So if you want to get started with NiFi, there's a lot of different ways you can do it. So just testing something out, really simple case. If you have on your left side here, you've got small boxes which would represent sites. So for us, those could be refineries and chemical plants, for example. And then those regions could represent entire continents or however you want to break up your regions. And you can have a single instance of NiFi sitting close to your cluster that can talk to all of these different things if the network's good enough. And that works, and it allows you to build flows. It allows you to start learning the tool. But if you want to start doing some serious work, someone's going to say, what happens when that NiFi piece breaks? Well, it's pretty simple. Everything else breaks too. You don't have your data anymore. It's no longer flowing. So you can handle that with NiFi still. If you set up a central NiFi cluster, for example, you'll have 3 nodes there instead of 1, and if one of them fails, all of your data will still continue to flow. If some of your sites are really, really remote, and you don't have a reliable network or good bandwidth between that site and your central cluster, putting up regional NiFi instances could also be very helpful. What this allows you to do is set up a site-to-site connection between your remote regions and your central NiFi cluster, and then you have all the control that I was talking about a minute ago. You can control when it's going to flow, you can control if you're going to compress it first, if you're going to split it up into smaller pieces, and you can really take advantage of the bandwidth or the reliability of the network that you may or may not have, and make sure that you still get your data not only securely but also reliably. And again, these are just basic examples. You could do any combination of whatever you want to do this, but you have lots of different options. So for example, if you have multiple clusters and you've got regions that you need more reliability, if one of your sites has a NiFi instance that goes down, or maybe you just want to do instance on a NiFi, you can bring that one down and redirect all the flows to the other NiFi instance in that same site. And then furthermore, and I don't have a lot of experience with this, but if you guys aren't already aware, there's a tool called NiFi, which is basically a ladder weight version of NiFi that would allow you to get these NiFi instances all the way out onto your individual sites or even your individual components, depending on how small you want to go. And that's becoming, from what I understand, more and more viable every day. So if you are going to play with NiFi and you're going to use any one of these setups, it doesn't really matter which, there's some things that I want to point out that I would recommend that you pay attention to. It'll make your life easier when you do start playing with NiFi. One of those things is repository sizing. And not just sizing, but also the types of disks that you're going to use. So when I'm talking about repositories, I'm talking about basically the disks that sit under your NiFi. When data is flowing through your NiFi, it's going to be on those disks. If you have a situation where the source, for example, in one of these last slides, if your data lake is down, maybe you're doing maintenance, maybe you had an outage, heaven forbid, what's NiFi going to do with that data? It's just going to start collecting it up to a certain point, either until you have your back pressure configured or you run out of disk space. So you want to make sure that you're putting enough space on those disks to handle that type of situation. Also, if you are using some of the more fun features with NiFi, for example, provenance, you can look at a history of what's come through your NiFi instance and even see copies of that data even after it's gone through. But you need to make sure that you've got enough disk space to hold on to those copies or configure it as such that you don't need it. And I'd recommend having big enough disks so you can use that. It's a very useful feature when you're trying to debug what's happening with your flows, where your data went, if you got the right data, and so on and so forth. Another thing, run schedules. Whenever I get a new user in one of my NiFi instances, one of the first things I have to tell them is, hey, when you pull this instance down here and you're just testing stuff out, you're going to notice there's a run schedule of 0 typically, which just means that it pulls as quickly as it can, as often as it can. If you don't know what you're doing, you'll quickly fill up disks, you'll quickly crash systems, you'll consume memory. So understanding how that run schedule works and then using it to your advantage, both to increase throughput as well as throttle it so that you're not overloading your system. And there's a lot of flexibility there with the run schedule. If you do it every 5 seconds or every 5 minutes or every 5 hours, or you can use a cron line to define exactly when that's going to run as well. Back pressure, so this also will help make sure that your system runs reliably, but you can control how much data is going to go into a processor before it says to the previous processor, don't take any more data. So making sure that you configure your processors so that, one, if everything's backed up, your system is still going to function, but it's going to stop receiving new data. Having control over that's really nice. One thing I can't claim to have seen a lot of other people's setups, but I don't see it mentioned as often, is the monitoring that you can build directly into NiFi as well. So one of the things that we use quite a bit is inactivity monitoring. So we can see on each individual flow or each individual site, if data stops coming for a period of time, we'll get an alert saying, hey, no data is coming from this site anymore. And you can choose what you want to do with that. And that might be executing a script that starts up another site to try to grab the data, or it might just be a simple email alert saying, hey, data's not coming anymore. And you also get alerts for when that activity is restored. That's one of my favorite features because it means in the middle of the night, if I get one of those emails and I get another one right after it, I don't have to go get on my computer and fix anything. NiFi expression language is another thing that I would recommend you at least take a little bit of a look at. If you're into coding and you're dragging and dropping, you're building a flow, every once in a while you'll run into a situation where you have like 17 processors to do something rather simple, and you're like, man, this would be a lot easier with code. And for example, you might be just putting different kinds of files into different places on the same system. Now, using NiFi expression language, you can a lot of times simplify your flows by using different variables coming from various expressions. And our computer just turned off. I'm guessing something needs to be plugged in. I'll let him play with that for a minute. I still got a mic. Is that actually plugged into the computer somewhere? Okay. All right. Anyways, so NiFi, yeah, it's great. If you don't use it already, you should at least go check it out, play with it. It's a lot of fun. Or go check out one of the other sessions that talks about it in more depth. A lot of the real fun starts, though. You want a question? We'll do questions afterwards. I think I'm going to be short on time all of a sudden. One of the things you're going to do right after you get your data is start trying to figure out what you do once you've landed your data. Some cases might be pretty easy for you. If you got to control all of the deployment of your data sources, maybe you named everything perfectly and everything is exactly consistent and perfect. For us, that wasn't the case. Again, we've got refineries and chem plants all over the world, and they're all collecting data. They've all were built at different times. They all may be at different levels of the software that they have, or they might have entirely different systems based on what was available in that country or that region. So when we're collecting our data, we'll run into these issues of data contextualization and anyway, so we'll run into those issues. And when that happens, one of the first things that you're going to have to figure out is your global problems. So global problems are pretty simple. For example, time zones, right? But you need to make sure that you're accounting for that and that you have your timestamps in the same format. That way, when you get your data back, it's lining up correctly with the actual times that you think it is. Another thing that you have to worry about with your global issues is language barriers. And they're more complicated than you think. Who here, by raise of hand, knows the word for heat exchanger in Norwegian? I didn't either, but I saw it once, and I can't pronounce it or spell it. And then if you think about that word, then what's the abbreviation for heat exchanger in Norwegian? It looked to me like random consonants from that string were just put somewhere. So your metadata that you have coming in is going to be really important. Hopefully you've got good metadata, but even with all the metadata in the world, it's probably not going to be enough still. You're going to need to be thinking about also getting an expert for that data that understands the metadata and the actual data, the differences, the discrepancies, and the nuances. And another thing you'll run into that goes beyond the global pieces is but just different types of vendors. So if you don't have the exact same system at every refinery, there's going to be a good chance that one will allow you to use a certain naming convention, where one, it might be locked in, you can't change it at all. So you're going to see that type of issue as well. And then also, what happens when the actual systems or equipment function differently? So if you have a pressure sensor that's collecting data, it might have a different resolution or a different frequency as you go from one site to another, which can also be challenging. Hey, yeah, no, I still don't have a computer. But so you need to be thinking about how you're going to handle these differences. Another good example is if you think about if you work with control systems, you might be familiar with confidence levels. So if you have a system that's giving you a timestamp, a value, and then a confidence level, right? And you might think they're all the same, but we found that they're not. So as an example, let's say you're bringing in all of your stuff and you say it's 0 to 100 confidence level. Anything over 60, we're going to assume is good data. Anything below 60, we're going to omit and throw away because that's bad data. But then you go find out later that you're throwing away and you're not getting any good values for entire sets of types of sensors. And you go find out later that good data for them is a 0 or a 1. Because it was less than 60, you lost all your data, or you just kept on throwing it away. So understanding those nuances is going to be critical. How's it coming? Thanks, guys, for being good sports about all this. I didn't have a lot on the slides anyways, let's be honest. So another thing that we run into quite a bit, and this has probably been one of the biggest challenges that we've had, is that not all data stays the same. Some of your data is going to be mutable. That kind of threw me off at first, because when I thought, if the pressure sensor at 2 o'clock yesterday was 20, or temperature sensor yesterday at 2 o'clock was 20 degrees, when I go search for that data again tomorrow, and I look at yesterday's date for 2 p.m. at the same time, it should still be 20 degrees unless someone had a time machine and went back and changed the value, right? Well, it turns out that actually happens quite a bit. Some of you might be familiar with calculated values or calculated sensors, calculated tags. There's lots of different names for them. Virtual sensors, virtual tags. The idea would be, let's say we have a 100-foot section of pipe, and there's 5 sensors on that saying the pressure or temperature on this pipeline. But rather than looking at each of those individually, a lot of times what you'll do is you have a calculated tag, which will take the average of all of those. And that gets stored as a tag as well, or as a sensor as well. But then you come to find out later that 2 of those 5 sensors were broken. Therefore, your average is way off, and it's not accurate, and it's bad data. But there's systems in place that handle that, and they go and fix the data and whatever else. But by the time that it gets fixed, you've already ingested it. So now you've got a discrepancy between your source system and the stuff that you've ingested. And you need to be thinking about 2 things when that type of situation happens. 1, can you detect it? So So you need to make sure that you've got the right kind of validation system in place that can detect those differences. There you go. There, if you want that slide, I talked about some of that stuff. So we're right here right now, synchronization. So not only do you need to be able to detect when that happens, but you also need to take into account, how do you fix it? What do you do when that happens? And you might think it's pretty simple. You just re-ingest that little piece of data and your data's fixed. But the problem is, with time series data especially, that actually becomes quite challenging, because you're talking about aggregations, interpolation, partitioning, and all of these things happen. When they do, sequence matters. You can't just go and add them to the next data set. You need to somehow go back and recalculate a lot of those things. So understanding that, you're going to run into that probably, and you need to understand what the costs are going to be, both for processing and timelines and all of that. And then that kind of leads us into the storage, interpolation, and aggregation pieces specifically. So let's look at that real fast. I'll get all these on the screen for you. First of all, and I won't go into this, there's lots of different places you can archive and compress your data to take better advantage of whatever data store you're using. It could be HDFS, it could be something else. But one of the things you're going to notice is when you bring in that raw data, it's not cleansed yet, it's kind of ugly. You're going to do some processing on it right at the beginning, all the stuff that we were just talking about, to try to get it in the same standard as everything else. But once you've done that, you can't just throw away your raw data. As a best practice, you'll typically hold on to that in case you need to reprocess it or do something different in the future. But for the most part, you're not going to use it over and over. So one of the recommendations is to simply compress that data after a certain short period of time and then archive it, and you're going to be continuing after that working on the sets of data that are already somewhat processed. Real briefly on interpolation, and how are we doing on time? Yeah, we're okay. So let's talk just a moment about interpolation. I mentioned that your sampling is going to be different on different types of sensors. So you might have minute data on one sensor and second data on the other, but you want to overlay these right on top of each other. Maybe they're even the same kind of sensor. So when that happens, a lot of times you want to have a value for every point that the other sensor has a point, so it matches the same resolution or the same frequency. And when you're going to do that, you need to figure out how to fill in those values. So interpolation is typically the answer for that. And again, your metadata hopefully will help you answer that question as to what type of interpolation you're going to do. But the two most common interpolations that we'll see are going to be step interpolation, where you keep the same value that you had previously all the way until you get a new value, and then it jumps up to that new value or jumps down to that new value. The other type of interpolation that you'll see pretty commonly is linear interpolation, where you simply take the average between those two values in order to fill the void. So it's almost like drawing a straight line from one point to the next, and that would be all of your values in between. And again, which type of interpolation you're going to use will depend on what type of sensor it is. It'll depend on what your metadata says. And if you don't have anything in your metadata to tell you that, you probably need to go back and ask your data experts, how's it going to impact my data if I have average values? You know, a really simple example, if I have a valve that's either open or closed, I probably don't want to use linear interpolation between the opening and closing of the valves. I just want to say it was off and then it was on. And that's all that matters. With aggregation, I said earlier that we want to allow our users to ask really big questions. We don't want them to shy away from them. We want them to ask those questions, and we want them to get answers quickly. So part of the way that you're going to do that is through aggregations, right? So not only, and how you do your aggregations will depend on what types of questions they're going to ask. So if I ask, show me the last 20 years of this particular sensor reading, I probably don't need second resolution for the last 20 years. And if I had that, it's going to be challenging to even display on most of your systems today. So aggregations will typically would be how you'd handle that. So you would have maybe hourly averages, daily averages, even monthly averages, depending on what type of system it is. And that'll still show them the overall trend that they're looking for. But then again, when they start drilling into that data, you still want to have the ability to show them that high resolution data all the way down to the second if it needs to be. So doing aggregations will allow you to answer those big questions quickly, and then keeping some of your original data at the smaller resolutions will allow them to get drill down at the same time. And partitioning is almost going to be the exact same thing. How you partition will depend upon how people are going to read your data or how they're going to query your data. So I can't give you all the examples of the best partitioning strategy, but I will say that sequence matters, especially when we go back and we talk about mutable data that changes. When that happens, You need to be thinking about how does that impact your partitioning, how does that impact your aggregations, and how does that impact your interpolations. Typically, you're going to have to redo all three of those things to some extent on some portion of your data in order to get it back in sync with your source systems. And that will lead us into consumption. I don't have a lot of time to talk about consumption, which is sad because it's a really important piece. But I'll say this. You want to understand who your users are, just like we want to understand what kinds of questions they're asking. But we want to understand, are they going to be users of Hbase and Hive directly? Are they going to be doing that from the command line? Are they going to be doing that from views? Do they have the expertise or the skill set to even do that? Do you have the resources to train them if you want them to do that? In some cases, or almost always, you're going to have at least a couple users that are going to fall into that category. But you're going to have a lot of other users that may fall into different categories. You also have the question of, should I be using Apache Hive or Apache Hbase with time series data? In our experience and in my experience, you want to use both. Just again, depends on what questions they're asking. So for a lot of the exploratory stuff and a lot of the processing, you're going to be using Hive as intermediate tables. But you're also going to want to put things in Hbase so you have the ability to get really quick answers on large chunks or large sets of data with individual values. And then off cluster. I know some of our Hadoop purists may not like hearing this, but there's going to be cases where you've got a massive amount of data. You do some really big, awesome heavy lifting on your cluster, do all the processing, but the resulting data set may not actually be that big. And it may not make a lot of sense to have your users go onto your cluster to get this. So you may want to think about a strategy or a third-party tool that may get this data off the cluster for those resulting data sets, and then they query that, and they're not hurting your cluster anymore by asking it lots of questions. But one of the things that we do that we've been having success with, and that we're going to continue down this direction, is consumption APIs. Now I know that Hbase and some of our other tools already have APIs that you can just use natively, but going beyond that, putting an API layer in between our users and the systems, or in between our applications and the back-end systems. And this has a really nice advantage. So one, there's tools that are in our ecosystem today that weren't there a year and a half ago, several actually, and there's going to be tools there tomorrow that aren't there now. And when that happens, if you're a big company like ours, it's not easy to quickly redevelop all of our tools to make things work again. So we don't like the idea of things changing rapidly, but at the same time, we know it's really important and that if we don't do it, we will fall behind. So one of the ways that we handle that is with these APIs. What it allows us to do is keep our APIs updated so someone can ask a question and have the API kind of handle how it gets that data back to the user. And if we decide that tomorrow a better tool to use than Hive or Hbase or Druid is something else, hopefully we'll be able to find a way to drag and drop that back-end piece without updating the application, without retraining our users, without telling someone the new connection string details. Again, they can just hit that API, it'll go get the data, and the only thing that should change for our users and our applications is hopefully them getting their data back becomes more reliable and faster as things continue to progress. Serialization. So there's lots of different optimizations you can take specifically with time series data. Serialization is kind of a fun one because it fits so well into time series data and Hbase. And one of the most simple examples I can think of, if you want to look at this, if I were to have 1,000 values in time series data and I make a request to get all those values with Hbase, it's going to be one record, timestamp, value, maybe confidence level also, and then another record, timestamp, value, and so on and so forth, right? But if you get those 1,000 values and you know it's 1 second intervals, you're going to look at that first timestamp, and then you're going to just kind of basically ignore it as you look at the future records because you know they're just 1 second after the next, after the next, after the next. So one of the ways you can handle that is you just store one timestamp value, and then you serialize all those other values, depending on the size, and you can determine how you want to do this. Maybe it's 100 values and one timestamp, and you know that the first timestamp is for that first value, and so on and so forth. It's actually really cheap to serialize that data, and it's really cheap to deserialize it. But on the converse, it's expensive if you leave 10, and so all of a sudden you go from 1,000 records, for example, to 10 records with 100 values each. So you can really get a lot of time and cost savings and a lot of more performance out of some of your tools by making observations and optimizations in those types of situations. with all that being said, I want to go ahead and conclude and just say that it's an exciting time to be in big data. It's an exciting time to be working with these tools. I know at ExxonMobil we're sitting on a mountain of data, and it's really fun for me to see them actually get access to it the way that they've probably wanted to for years. And I hope that in your big data journeys and in your time series journeys that you're able to leverage some of the similar tools and get some of the same results that we're getting. And with that being said, I'll go ahead and open up just a few minutes for questions. I will say that I won't be able to answer too many specifics. I might try to redirect you to other people in the audience if that's the case. Yeah, sure, go ahead. So your question is in these pictures back here talking about connecting to the sensors. So I'll say that these are sites, not sensors, and because we're working with a lot of legacy systems, which may or may not be OSI Pi and may or may not be other systems, which I can't answer. I will say that for the most part, at least on our first attempts at this, we're usually having the control system itself or the historian itself dump data, and then we pick up that data using NiFi. All right. So at this site would be a refinery, and you'd have a historian that's co-located with that refinery, and we'd have another tool, for example, that would allow us to dump data out of that piece, and then NiFi would just simply pick up the data after it's been dumped, right? But there are ways to directly connect it and get closer depending on what types of systems you have, but that's just what we're doing today. Sure. We have been, and it's cool, doing some fun stuff with it. I don't have a lot to share, but yes, it's an interesting space to be in. I saw a couple over here. Let's go this direction. Yes, Atlas is being used, but I can't go on. Can't go beyond that. we're using almost all of the tools in the stack. At the end of the day, and we've got a lot of different use cases. Some are using some tools, some aren't. But yes, Atlas is definitely one of the things that's important. So, I mean, so one of the, I'll just say that that kind of situation would typically fall into the same category as the synchronization issue. So if you have a good validation system, it'll catch things like that, and it typically means you need to re-ingest a piece of that data. So having systems set up to one, catch that thing automatically, and then hopefully even have an automated process to pick it up is a good way to go about that. Sure. Any what? Visualizations? Yeah, so I mean, it didn't really come with the, so you're asking if we're doing any visualizations with our time series data. So I'll say yes, but that's not really in scope of this particular architecture. That's happening more at the application level. So when we're talking about some of our APIs and the ways that we're connecting our applications to the data, those would be some of the tools that would do that. But I'm not at liberty, I don't think, to name any names, unfortunately. All right, if you guys have any more questions for me, feel free to come find me after the conference.